Hello, Kurt. Tell me about Molex. Can you speak to the history you have in noise cancellation?
Sure. It's been about 5 years now that we've been working towards sensors within the noise cancellation. So what we've done, the first sensors that we worked on were for road noise. So we're capturing what is the road noise, and that gets transferred with some of our partners to be able to broadcast a cancellation waveform for passengers within the vehicles. So definitely is a little bit newer technology, something that a lot of OEMs are starting to pick up, especially for EV vehicles.
It's kind of a dumb question, but why is noise cancellation important in cars?
And that's what we're seeing is that as we move towards EV and you remove the combustible engine, so now all of a sudden a lot of the additional noises that a vehicle makes are heard. Once people hone in on those, it's very disruptive. But the one thing is that the primary noises that come from the road surface end up being noises that create that fatigue factor in our driving. So
in drivers. Well, I mean, that's fascinating. I never really thought. I mean, I've been in electric vehicles, but I really never thought. It's like over time.
Right. So what they found is that that wave that is generated from that noise is very similar to the sounds that are created for putting people to sleep machines. It's that same area. And so as we drive and we have the longer drives, people get fatigued by that. They get hypnotized.
Wow. I think I've heard that, but I never really thought about it on my personal level. Wow. How does adding sense of touch to a vehicle allow for detection of collisions and so forth? I mean, can you talk a little bit about the architecture there?
Right. So the similar sensors to what we're using for road noise are now being used within, let's say, the surface of an autonomous vehicle. And what we're doing is we're adding that sense of touch to be able to, let's say, identify when and how hard something would have impacted the side of the vehicle. So with the current ADAS suite of sensors, you're able to visually see things, but you don't know specifically when it hit the side of the vehicle. You don't know how hard it hit the side of the vehicle. So as I'm adding the sense of touch to the vehicle, now I'm adding a way to see, okay, if the vehicle was damaged in any way, if somebody is just trying to get the vehicle's attention, if something's being dragged underneath of the vehicle. So now you add that additional sense to be able to see that. We as operators of the vehicle, as drivers, we use our human senses. We use seeing, we use touch, we use hearing, all to allow us to drive cautiously, allow us to drive safely. So by us bringing in, let's say, the sense of touch and even the sense of hearing in some sense, now we're allowing the vehicle to add those additional inputs to allow it to be a safer car, allow it to basically identify different things that are out there.
I could ask a million questions about that. I mean, do you have to plant more sensors along the side of a car to know, or is this more about vibration? Because I'm a person driving, I can tell when I've been hit because I have a body that senses my surroundings in various ways.
Right. So what it is you're adding additional sensors, but each OEM is going to look at it a little bit differently. Yeah. The ones that we're currently working with in the autonomous space, they're putting them all over the surface.
Yeah.
So this way they can triangulate where specifically an impact occurred. Then that way they have that.
It's a resistance sensor.
Right. Yeah. So whereas some of the OEMs might only use a couple to be able to gain the amount of information, that they deem necessary. It's just that the ones we're using now are adding them all around the vehicle.
So why are the car companies considering it? I mean, it's just what people need. I mean, what have they done research on what customers want? Or?
Well, and I think that's what we're starting to see now within the ADAS and AV space is they're realizing that to really get the vehicles to be safe and gain everything they need the additional sensors beyond vision systems.
Yeah.
Beyond your camera.
I can see a scenario where you'd say, sensor like a person would say, "Oh, I was hit by a rock," as opposed to being clobbered by a kid on a bike or worse. a truck. But
yeah. So you imagine, I mean, just driving down the road now, you have a gravel hauler that might throw a stone and hit the windshield. We hear it, we feel it, and we know, okay, what we need to do. An autonomous vehicle doesn't necessarily know that because it wouldn't have seen it. And
would the sensor be on the glass?
That's kind of some of what we're doing is we're creating these different sensors and mounting points to either put them on let's say a glass where the vibration can transfer out to. So you put it in the pillars or along the edges.
Okay.
But just some of the placement we have, we're even able to determine if, let's say, a box blew underneath of the vehicle and now you're dragging it. The sensors have the correct characteristics to be able to even feel that.
Well, why do consumers care about this, or should they care about this?
Again, it adds that safety factor. It allows the technology to advance where you're going to feel comfortable that an autonomous vehicle or the advanced driver features are safe enough for, let's say, pedestrians or people outside of the vehicle, but also the vehicle itself is comfortable enough to.
Wow, it's pretty fascinating.
It is.
Thanks a lot, Kirk.
Yeah, thank you.